Alright guys, welcome back. In this video here, I was going to show you guys two examples of the regarding concept that I discussed last video, and that was how do we use definite integral to describe the total income earned by a continuous income stream, and also the future value of a continuous income stream that is constantly invested regularly. That could be monthly, yearly, however you want to look at it. In the previous video, I discussed these two type of continuous income stream here. In example 3, I'm going to show you guys this example, and this is straight from a textbook here. I'm not really making this up or anything. So in this example, we have a function that is describe or was capture or estimate the rate of change of the income produced by a vending machine. So t is gonna be in years, right? So t is in years, okay. And since my typo is a bit too much in this case, since the installation of the machine, right? So somehow we're able to describe these rate of change. So that's that function there. That could just be based on the inventory count, or just the amount of money that we estimate or just count at the end of each year, and just estimate the rate from there. So that's just that can easily be done there. So we got the rate of change functions, and that's called f of t. So this is the flow. This is the rate of flow here. All right. So usually this describe the income stream. So so this is the continuous income stream function, right? And we want to find the total income produced by this machine, this vending machine, during the first 5 years of operation, right? So recall that total income formula is equal to the definite integral from a to b of the rate of flow, or the continuous income stream f of t dt. We're looking at this function 5000 e to the power 0.04t. So we're looking at that graph. In terms of this graph, it probably look something around this here at 0. So this is t, this is f of t. So at t0, installation cost looks like it's $5,000, because when you plug for t equals 0, you're gonna get 5,000. So let's say this is 5,000. So it's an e function, so it's gonna increase something like that, right? So we want to look at the area. Definite integral will be described by the area from 0 to 5. All right, so we're looking at this area here. So this area is the total income. This is the total income during the first 5 years. All right, and we're gonna find that total income during the first 5 years using this definite integral setup here. Okay, all right, so let's go ahead and do that. Okay, equal. So a to b in this case is gonna be from 0 to 5. Okay, 0 to 5. F of t is going to be 5,000 e to 0.04t dt. So this is going to be 5,000 times 0 to 5 integral e to 0.04t dt. And we learned this from the previous lesson. So that is how to find the antiderivative of e function. It's going to be that e to something and divide by the constant in front of the variable. And then we're going to evaluate from 0 to 5. If we divide the 0.04, oh, I think I messed up here. Just divide by the constant, not just include the variable. Okay. So now if you do the math correctly, you're gonna get 125,000. So that's 5,000 divided by 0.04 times e to 0.04 t. Evaluate from 0 to 5. And I personally like to write the next step like this here, just because I'm used to it. But when we apply the fundamental theorem of calculus, I'm going to leave the constant in front. So I'm just going to do 0.04 times 5 minus 0.04 times 0 there. So technically these are your f of a minus f of b here. Okay. Again, if you do the math correctly, by the way, this is always going to be 1, because this is going to be 0. So e to 0 is going to be 1. So if you do the math correctly, or if you type this in the calculator correctly, you will need to do this part first and take the e to that and then subtract it by 1 and then times it by that. And if you do this correctly, you should end up getting 27,675. This is round to the nearest dollar. Okay, so that should be our answer. So this vending machine here, right? So earned the company around 27,000 or almost 28,000 for the 5 years operation. And that is described by this area here. Now, if you are a company that make these vending machine, you will need a lot of this vending machine to survive because that's only 27,000 for 5 years. So if you divide that by year, on average, we're looking at here around 5,000 per year there. That's not a lot. So you need a good number of 100 or 1,000 this vending machine distributed throughout the country. So that's kind of cool in my opinion to be able to estimate the total income earned by these vending machine. And again, so to get this rate of change here, this is just based on, you know, number crunching and each year kind of estimate that rate, right? So that can be done. So that's total income. Okay. The next example is discussing income stream involve investing that amount each year, and then now that becomes the future value. Okay, so in terms of future value is how much is in the account. 35 years in this case here is the amount that we get from the money we invested plus the interest. So the future value describe the amount deposit plus the interest. Okay, so investment plus interest. So that's what future value stand for. So let's go ahead and do this problem here. So starting at age 30, right? Most of us will start at age 30 when we have a career. We deposit 2,000 per year into a Roth IRA or personal retirement account here. Nowadays you can deposit about 6,000 or 5,500 max per year. So this person deposits 2,000 a year into an Roth IRA account for retirement. Okay, so at the end each year he's just gonna deposit $2,000. Starting at age 30. And it said treat the yearly deposit into the account as a continuous income stream. So that tell us, okay, our rate of flow or continuous income stream is $2,000 per year. So it's gonna be equal to $2,000. That's what F of T. And it said that if the money in the account earns 6% interest compounded continuously, how much will be in the account 35 years later when you retire at age 65? So meaning this person will start 30 and retire at 65. So we're looking at 35 years of working, and each year he deposits $2,000. And it said how much of the final amount is interest. Okay, so this is the second question here. So the first question is you want to find the future value, and then you want to find the amount of interest earned after that. Okay, so just quickly here, we know that if he's gonna deposit 2,000 per year, then in 35 years or in 35 installation, we're looking at 2,000 times 35, so a total of 70,000, deposit into the account. Right? Would you agree on that? All right. So now we're gonna try and find out, okay, how much this 70,000. Actually, sorry. We're gonna try and find the future value in the account after 35 years. Okay, and this future value will include both, deposit amount or investment and the interest earned. Right. Okay. All right. So let's go ahead and do that. Okay. So from the previous video, we discussed the formula for finding the future value for a continuous income stream that is constantly or regularly invested. Is the formula as following: future value equal E to the R capital T times the integral of 0 to capital T times F of T times e to the negative r times lowercase t dt. Okay, all right. So now we know that the rate is at 6%. The amount of years that we want to figure out as far as the future value goes is 35 years later. So that's going to be our capital T there. Okay. Our continuous income stream or rate of flow is 2000. All right. Yeah, so I think we got everything we need to plug in the formula there. So we got R, we got f of t, you got capital T, and we're just gonna plug this into this definite integral formula and calculate the future value. So equal, all right, e to the 0.06 times 35 times the integral from 0 to 35. F of t is 2000 times e to the negative r will be negative 0.06 times lowercase t times dt. So this has become the definite integral of just exponential function base e. Notice that the thing in the front here, this is a constant, this is a number. We can also combine with that constant as well before we integrate. Okay, so if you take 0.06 times 35, you're gonna get 2.1, and I'm gonna go ahead and bring the 2000 in the front there. So now we're left with 2.1. I should write this a little nicer here. 2.1 from 0 to 35, e to negative 0.06 t dt. Okay, and then the next step is integrate, find the antiderivative of this part. Okay, so that's gonna become. So let's go ahead and hold up to calculate this and get the number first. So the antiderivative, this is going to be e to negative 0.06 t, divide that constant, negative 0.06. Okay, and then we're going to evaluate this at from 0 to 35. Okay, all right. So now we're going to take 2000 divided by negative 0.06. So that's going to give us a negative 33,333, and then I'm going to times it by e to the 2.1. Okay. All right. Actually, you know what? I don't want to confuse you, so let's go ahead and just leave that there for now. I'm going to go ahead and write this 2.1.06. And then when we evaluate this here, I'm going to go ahead and use bracket. E to negative 0.06 t. Oh, no, we don't want to do t anymore because we want to apply the fundamental theorem of calculus. So that's going to be 35 right there, minus e to negative 0.06 to the 0. All right, so let's go ahead and do that. So again, this is going to be 0. E to the 0 is going to be 1. So this part always 1. Okay, so we just need to calculate this part. Take e to that and subtract it by 1 right there. So let's go ahead and do that. This is going to be e to negative 2.1 there. Okay, so that's this part. And we're going to times that to this right there. Okay. I did this on the side already. So please double check my work here. I think I could have made mistakes. I'm known to do that. So if you type this into the calculator, this can be a negative number, and then times this difference, you want to subtract these two first, whatever that answer is, times by this result, and the answer should be positive. Okay, you can't get negative future value. So if you do it correctly, or let's get the same answer as me, again, let me know if you guys get a different answer. Okay, so this is my answer, 238,872 by the end of 35 years to be the amount in account. So this is our future value. All right, future value. Okay. So that's how much is in the account if we continue to deposit 2,000 each year that earn 6% compound continuously. At the end of 35 years, he'll be retired with a Roth IRA of $240,000. Okay. Now that's depositing $2,000 per year. Imagine he deposits $6,000, and we can do that too. That would be just substitute this this f of t instead of 2,000. Look at 6,000. So now part B, or this second part here, is asking for how much of the final amount, how much is the future value include, or how much the interest earned in 35 years. Okay. So what we want to do is we want to take this amount. Okay. 238 minus 87233 minus the total deposit 70,000. So that's going to give us 168,872.70 3304. Okay, so this here is the total interest earned in 35 years. All right. Again, please double check if you get the same answer. I did this a couple of times, but sometimes I make mistakes. As far as the step goes, the step should be pretty legit right there. All right. So these are two examples that involve continuous income stream. You gotta be able to tell which one is the question's asking for. I think the wording will tell you that total income versus the future amount, or have things that being invested at compound interest rate. All right, so I'm gonna go ahead and end this video.